For question 7, it's asking us to factor completely. This is not a difference in two squares because x to the 3 is not a perfect square. 32 is not a perfect square. But we always should try to factor out a GCF if possible. So if I look at just the GCF of these two terms, I can take out a 2xy. And that will leave me with an x squared minus 16. So now that I've taken out this GCF of 2xy, I've actually revealed a difference in perfect squares, or a difference in two squares. They kind of refer to it as many things. Some people just say a difference of squares, some people say a difference of two squares, some people say a difference in perfect squares. They all mean the same thing. So if you hear me refer to it as a couple of those terms, I'm referring to the same thing. But this is a difference of squares, so I'm going to put my two parentheses, a minus and a plus, and minus and a plus. In the first two slots, what times itself gives you x squared? That'll be x. And in the second two blanks, what times itself gives you 16? And that would be 4. And I cannot forget to bring down my 2xy. And that would be my final answer. With question number 8, again, this is not a difference of two squares, at least right now. But if I factor out a GCF, and I can factor out a 2y, that will leave me with 1 minus x to the 6 y squared. And this actually is a difference in two squares. So a minus and a plus. It kind of looks like a battery almost. So in the first two blanks, what times itself gives you 1? That would be 1. In the second two blanks, what times itself gives you x to the 6 y squared? And that would be x to the 3 y. So again, it's like we're dividing the exponent by 2. And again, we cannot forget our GCF of 2y.